In the last video on quasars, I think I sparked some interest when I threw out the idea of the Milky Way galaxy actually colliding with the Andromeda galaxy, which people think will happen in 3 to 5 billion years. And I threw out in the context of maybe the supermassive black holes at the core of the galactic cores of each of those galaxies will start getting a little bit more material when that collision happens, and maybe quasars will happen. I don't know. But given the interest in that, what I wanted to do here is kind of an unconventional thing for the Khan Academy and actually show a video. And before I play the video, I have to give credit where credit is due. This is a supercomputer simulation made at the National Center for Supercomputing Applications in NASA, and it's by B. Robertson of Caltech and L. Hernquist of Harvard University. And what I want you to remember is this is super sped up in time. Just to give an idea, the amount of time it takes for a star about as far away as the sun to make one orbit around the galactic core is 250 million years. And you're going to see that this is happening multiple times over the course of this video. So this video is actually spanning billions of years. But when you actually speed up time like that, you'll see that it really gives you the sense of the actual dynamics of these interactions. The other thing I want to talk about before I actually start the video is to make you realize when we talk about galaxies colliding, it doesn't mean that the stars are colliding. In fact, there are going to be very few stars that actually collide. The probability of a star-star collision is very low. And that's because we learned, when we learned about interstellar scale, that there's mostly free space in between stars. The closest star to us is 4.2 light years away. And that's roughly 30 million times the diameter of the sun. So you have a lot more free space than star space or even solar system space. So let's start up this animation. It's pretty amazing. And what you're going to see here, so these are just obviously, so one rotation is actually 250 million years, give or take. But now you see these stars right here are starting to get attracted to this core, and then they're actually attracted to that core. And then some of the stuff in that core was attracted to those stars, and they get pulled away. That was the first pass of these two galaxies. Some stuff is just being thrown off into intergalactic space. And you might worry, maybe that'll happen to the Earth, and there's some probability that it would happen to the Earth, but it really wouldn't affect what happens within those stars' solar systems. This is happening so slow, you wouldn't feel like some type of acceleration or something. And then this is the second pass. So they passed one pass. And once again, we're doing this. This is occurring over hundreds of millions or billions of years. And on the second pass, they finally are able to merge. And all of these interactions are just due to the gravity over interstellar, or almost you could call it intergalactic distances. You can see they merge into what could be called as a Milkomeda, or maybe the Andromedy way. I don't know, whatever you want to call it. But even though they've merged, a lot of the stuff has still been thrown off into intergalactic space. But this is a pretty amazing animation to me. One, it's amazing to think about how this could happen over galactic space scales and time scales. But it's also pretty neat how a supercomputer can do all of the computations to figure out what every particle, which is really a star, or cluster of stars, or group of stars, is actually doing to actually give us a sense of the actual dynamics here. But this is pretty neat. This is pretty neat. Look at that. I mean, these are, every little dot is whole groups of stars, thousands of stars potentially.